Yes, sir.
What is it?
When a light is illuminated on a metal surface, the electron will
Yeah.
what?
So
Emit, sir.
photoelectric effect means electricity due to photons. Okay. Photon in general means light. So there are certain type of metals, which are alkali metals, which will give out electrons when they are knocked out using light. So this is a setup. It's like a vacuum tube. So this is a emitter plate, which is made of particular metal, alkali metals, who can give out electrons easily when they are hit by light, visible light. So this light is going and hitting this plate. The electrons will come out. So this plate should be positive or negative. The right plate.
Positive, sir.
Yeah.
Positive.
Just attract electrons. So the current will flow in the reverse direction because electrons are negatively charged. Okay. So one of the characteristic. So the variables here are you can change the supply voltage V. Okay. And then another thing you can change is the amount of light that's hitting this uh, plate, emitter plate. So anything else you can change, and also you can change the frequency of the light. Okay, so there are three
Yes.
parameters sort of. One is the applied voltage, another is the intensity of the light, that is number of photons. Then the third one is the frequency of the light. So if you change these three, how the amount of current will change. Okay, so the y-axis is current. Okay, x-axis is applied voltage. Same thing here, but we're using different parameters. So in this first graph, how is the current is changing with respect to voltage when we change the intensity of the light. So the intensity of the light is changing, the saturation current. Okay, so the current will increase if you increase this applied voltage, because applied voltage means applied voltage what means the electric field is more, and electric field is giving the force, right? E into E is the force on the electron. So if
Yes, sir.
applied voltage means electric field is more, so more force is there, so accelerator will be more, so more velocity. So number of electrons crossing a unit area will be more, so the current will be more. So if you increase applied voltage, it will increase, but after some time it will saturate, because even if you increase the number of the electric field, if the electrons are not available here, then the current will saturate, right?
Yes, sir.
So the large number of electrons and the voltage increase slowly. So depending on the increase of the voltage, the number of the rate at which the electrons are hitting this collector plate will be more. But if the number of available electrons are few, okay, beyond that, if you increase the voltage, it will not make difference to the current. So that's why it's saturating here as you increase applied voltage. But if you increase the intensity of the light, intensity of light increase means number of photons hitting the plate will be more. So if one photon hits this plate, how many electrons will come out?
One.
One. But suppose the increase of frequency of the photon and the single photon hits this plate, how many electrons will come out? If the energy required for knocking this electron is some particular value, and this light has got some particular energy, h nu, and if you increase the frequency means the energy of the photon is going up, right? So that higher frequency photon, if it hits this plate, how many electrons will come out for one photon?
Be more, sir.
No, it is actually
More
one.
than one.
No, it's actually one only. So the remaining energy
Why?
goes in increasing the kinetic energy of the electron. This is one of the
Yes,
best.
sir.
This is the postulate of Einstein's photoelectric effect. Okay, one photon can knock out only one electron. Okay, and if the photon has got more energy, the remaining energy goes in increasing the kinetic energy of this electron. Okay, but suppose
Yes,
if
sir.
two photons are hitting, then two electrons will come out. Okay, so the number of electrons coming out depends on the number of photons hitting the plate, that is intensity of the light, but not on the frequency. So here, if the intensity of the light is increasing, means number of photons hitting the plate is increasing. So number of photons is increased twice, then the number of electrons coming out will be twice. So that's why the saturation current is increased. Okay, but here in the second graph, the constant light flux, okay, but the frequency is increased. And the saturation current depends on the number of electrons emitted that is same as number of photons hitting it. So since the intensity of photons is fixed, irrespective of this increase in the frequency, the saturation value of the current is not changing, because the saturation value of current depends on the number of photons hitting the emitter plate. That is same as number of electrons emitted. Okay, so number of electrons emitted, that will receive the saturation value. That will not change because of the change in frequency of the incident photon. Got it?
Yes, sir. But
Yeah.
it will alter that stopping potential value.
Yeah. Okay. So the stopping potential is right now I'm applying positive voltage here, right? To attract this electron.
Yes, sir.
Suppose I make this voltage negative. Okay, will still electron reach this plate? If you put negative voltage to this V collector plate, will the electrons still travel towards right?
No, sir.
If it has got some initial velocity, it will travel. It will keep on reducing. Okay, its velocity will keep on reducing. But if the initial velocity is towards right, it will keep on continuing. Okay, so to stop it completely, this negative value should decrease beyond a certain value. What is mildly negative, that initial velocity will still overcome this repulsive force and still touch this plate. Okay, so with this negative value is made more and more negative, this electric force, this repulsive force will increase. Then the electron will not able to touch. It will come here and then return back. Okay, so that maximum negative voltage will stop this electron from touching this plate. This what is this called? Cutoff voltage, right? Yeah, cutoff voltage. So what is the negative voltage that should be applied to stop that electron, or you can see the most energetic electron to reach the collector plate? That will decide the cutoff voltage.
Yes, sir.
So mildly negative means it will slow down this electron, but if this negative is increased more and more, that means it's becoming more and more negative, then the repulsive force will increase. So the minimum negative value or the maximum, the more negative value that should be applied to just make it repulsive, that is a breakdown stopping potential. Okay. So this stopping potential is here actually this mu1 is higher frequency.
So mu1 is high frequency. Okay. Okay,
Frequency
sir.
of a photon. So higher frequency photon will have given infrared higher initial energy to the electron. So it's difficult to stop this one. So to stop this higher energy electron, you need a larger negative voltage.
Yes, sir.
Okay, so that's why as this instant photon energy increases, mu1 is greater than mu2. So this breaking or this stopping potential will be more in the negative sense. Okay,
Yes, sir.
just forget the sign. Without the sign, it means it becomes. So you have to apply more negative voltage. So right, so this is one characteristic. Okay, so let's do some problem and come back so the understanding is better. So light is a particle or a wave?
Both particle and wave, sir.
Okay, so that's what one full chapter is there in dual nature. Okay, these are basic questions. Green light, red light have same power. Then which one have large number of photons? What is the energy of a single photon?
H mu, sir.
Yeah, h nu. Okay, so nu is frequency, right?
Yes, sir.
So which color has got more frequency, green or red, or both are same?
Red has more frequency than green.
Think properly.
Yes, sir. Green has more energy compared to red,
Okay.
but red has more frequency.
No.
Since energy and frequency are inversely proportional.
No, energy is h nu, no?
Ah, yes, sir. Ah. Yes, sir. Okay. Okay. Red has more wavelength, not more frequency.
More wavelengths, so there's less scattering. Okay.
Yes, sir.
So energy is h nu. So what is power? Power is energy by
Energy
time.
by time.
Okay. So he's asking number of photons, right? So this energy is not of a single photon, so it's of n photon. Energy of single photon is h nu. Energy of n photons is h nu.
Yes, sir.
Okay, so n h nu by okay. I've seen power. Then okay, power is same. So these two are same. Okay, large number of photons in a given particular time interval only. So power of green and power of red you have to equate. Same power is same, no? So both should be equal, and it should be the same amount of time. Otherwise, it will not make sense. Because you wait for a longer time, number of photons will increase. Okay, so for the same amount of time rule, so H is also same for both. So you have to compare N nu green and then N nu for red. Okay, so frequency of this thing is more, so number of red photons will be more.
Yes, sir.
Sorry, what is he saying? Yeah. Okay, which will have large number of photons? Red. Yeah.
Yes, sir.
Visualization. This is a basic question. The thing is energy of photons h nu, the energy of n photons in h nu, and power is energy per time, and same power. So it should be both of them should be considered in terms of same time. Okay, if it is 10 kilowatt, wavelength 300 nanometer, then find number of photons per second. Power is given, wavelength is given. So this is also a basic question. Can you get the answer?
1 second, sir. I will take pen and come.
This is the question.
Sir, H value is 6.626 into 10 power minus 34 only, no, sir?
Yeah. Okay, so don't do the calculation. So this is the step you did, right?
Yes, sir.
Okay, so fine. Okay, this one. Mole number of photon of wavelength will be okay. This is straightforward. Energy of photon is h nu, right?
Yes, sir.
What is momentum?
Momentum in terms of energy.
Okay, this is also basic formula. Momentum is h nu by c. So remember this also. Okay. H is known, and how do you find the frequency?
C by lambda, sir.
It is same as h.
Okay, lambda equal to H by P. Okay.
De Broglie wavelength.
Yes, sir.
So also you can remember. So from that also you can get the momentum. Okay.
Yes, sir.
So this one, in which of the following emission of electron does not take place? Not. Right. Thermonic emission is what?
It is not based on photons. If we give heat, means an electron will be emitted.
So there will be emission of electrons, right?
Yes, sir.
Okay. What about photoelectric effect? It's emission of electron by photons. Okay. And
Yes, sir.
what is secondary emission?
I don't know, sir.
I think it's emission of electrons when an energetic electron hits that electron. And X-ray emission,
I don't know, sir. They say rays will be emitted, but I
no.
don't know
See,
what
X-ray
rays
is
can.
just a emission of electromagnetic radiation. It has got nothing to do with electrons. Okay. So
Okay, sir.
this is the one which is not correspond to electron emission. Okay. So other
Yes,
two
sir.
emit electrons. Thermal emission by thermal by heating, photoelectric by photons. Secondary emission is when an energetic element hits, it will knock out the electron. So that is called secondary emission. Like in the photoelectric effect, there is no secondary emission. Like if the photon has got more energy, it will just knock out the electron, and the electron will have an initial higher kinetic energy. But it is not like that higher energy will knock out another electron. Okay, that is called secondary emission.
Yes, sir.
Okay, secondary emission is also in emission of electron. X-ray emission is just emission of electromagnetic wave. Okay, that has got nothing to do with that. Okay, photoelectric occurs only when incident light has more than certain minimum. What is photoelectric equation?
E is equal to pi naught plus kinetic energy.
So instant energy in photoelectric effect is h nu, right? So that is
Yes,
going
sir.
knocking off the electron, that is work function, is W the symbol or phi plus kinetic energy maximum.
Yes, sir.
So this is photoelectric equation. This is given by who?
Einstein.
Yeah, Einstein. Okay. So what is work function?
The minimum frequency required to
Minimum
emit an
energy.
electron.
Minimum
Yes,
energy
sir.
equal to knock off the electron. Okay. And remaining energy goes in providing the kinetic energy. Okay. And why is this kinetic energy called maximum? So the input is a photon is h nu that will go in knocking off the electron. So to knock off the electron, we need certain amount of energy W. Remaining energy is going into providing the kinetic energy. Okay, and why is kinetic energy called maximum? Because
Hmm.
all of the remaining energy need not go into kinetic energy. It can also produce some heat here. Okay, some heat can be produced. It's actually plus some heat, but when this heat is zero, kinetic energy will be maximum.
Okay.
Okay, so it's assumption that there are no other energy losses. So whatever the
Yes, sir.
energy of the photon, it goes in knocking off the electron, that is W or phi, whatever is the symbol, there is a work function. Then the remaining fully goes into kinetic energy. Since everything goes into kinetic energy, that's called maximum kinetic energy. Okay.
Okay, sir.
So the photoelectric occurs when the incident light has more than certain minimum. So to knock off the electron, the minimum energy is required is this. Okay. Even if
Pi naught.
kinetic energy is some
Okay.
small delta, okay, it will come out. So if the incident photon should have a minimum frequency. So h nu naught will be equal to W. So that nu naught is a minimum frequency.
Yes, sir.
H nu naught is to W, the work function. Okay, so frequency nu should be greater than nu naught for it to have some kinetic energy. So the minimum frequency will correspond to W by H. So the frequency is more than this value, then the electron will get emitted. So by changing the power, the number of photons will increase, okay, per second. So the number of electrons will increase. But if the power is less, means number of electrons will be less. But if the power is more, but if the frequency is less, still the electron will not get emitted. Even though the power is high, but if the frequency is less than mu naught, then there won't be any emission. Got it?
Yes, sir.
So even if
Yes, sir.
even when intensity is high, intensity means total number of photons, even when it is high, but if the frequency is less than mu naught, then there will be an emission. Similarly, wavelength, if the wavelength is okay, actually frequency should be greater than mu naught, and wavelength should be less than lambda naught. Okay, so lambda. So, but here is saying more than certain minimum, no? So there is
Yes.
minimum of a frequency above which the electron will get emitted, and there is maximum of a wavelength below which the electron will get emitted. Okay, so as far as wavelength is concerned, it should be less than the maximum, and lambda naught is C by mu naught.
Yes, sir.
This is a theoretical question. I don't think it will come in the exam, but it's required to have the concept clarity. Okay, which of the following statement is correct? Photoelectron increases with intensity of light. Stopping potential increases with increase of incident light. Basically, it means increase of intensity of incident light. Current in photocell increases with increasing frequency. Photocurrent is proportional to applied voltage. So, which is option B, stopping.
So both option A and D are right, no, sir.
No, photocurrent
Photocurrent.
photocurrent is the saturation value. What it means by photocurrent is the saturation value. Okay. So
In that only it gets straightened, sir, but below that one the curve is
no, below that one you don't have to. Okay, what he means is the saturation value. See, the saturation value, it is independent of this frequency, but it depends on the intensity of light. Okay, so below the saturation value, it depends on the frequency. Okay.
so the photocurrent
Photocurrent
before it attains saturation, it is directly proportional to that applied voltage only, no, sir.
Here, how do you see? Yeah. See, that is true even here, no? Here also it's proportional to the voltage. Okay. What is meant by photocurrent is the saturation value. That's the general understanding.
But they didn't mention it as a saturation, no, sir.
This is what it means, because this is just a transient state. Okay. This is actually a transient state which you don't give much importance.
Okay, sir.
Okay. So what makes sense is these values. This will increase for a very, very short time. Okay. So most of the time the photoelectric will operate in this region. So we have to consider how the saturation value will change with respect to other parameters. So with frequency is not going to change. Okay, it depends only on the intensity of the light. But the stopping voltage will depend on the frequency of the incident photon, and it's independent of the intensity. So stopping potential increases. No, it doesn't. Okay, stopping potential depends only on the H nu. This is not true. Current in the photocell increasing frequency. Current in the photocell depends on the intensity of the light. It depends on the number of photons or the number of electrons emitted. So that depends on the intensity of the light, not the frequency.
Yes, sir.
Photocurrent increases. This is the only first option is true.
Okay.
So when you connect your headset, so is it a problem now? Previously there was a problem.
No, sir, I don't have any problem after connecting to it.
So right now, are you using headset or no?
Yes, sir.
Okay, fine. Because background noise is not there. Okay, fine. Because today only I got my external mic and external speaker. So for me right now, audio is working fine. So you are able to hear, no?
Yes, sir.
It's better than the previous class? Or same?
Yes, sir. Same only, sir. I don't feel any difference.
Okay, because I'm using external mic, but it's clear, no?
Yes, sir.
Okay, fine. Right. This is the next question. Intensity of incident light increases.
Photocurrent increases.
Yes. So C is correct. D is wrong. Kinetic energy of photons. Kinetic energy depends on h nu. H nu equal to 5 naught plus kinetic energy max, no? So it's only dependent on h nu. There is no intensity in that equation. Got it, no?
Yes, sir.
According to the photoelectric equation, h nu equal to phi naught plus k max. Okay, so phi naught is fixed when once the metal is fixed, the coming emitter metal is fixed, and h nu. So phi naught k max depends only on h nu, not on the intensity.
Yes, sir.
Okay, so E is wrong. Okay, D, kinetic energy of electron photon decreases. No, kinetic energy depends on h nu only. H nu equal to phi naught plus k max. So phi naught is fixed. So kinetic energy k max depends on h nu or nu. Okay, not on the intensity. So D is also wrong. As intensity of instrument increases, kinetic energy. No. Option C is correct. Okay. Got it?
Yes, sir.
Okay. Number of ejected photon increases with. This was a trivial question.
That is the intensity of light.
Because one photon will emit one electron. Okay. So
Yes, sir.
number of photon means number of photons should increase. That is mean intensity means number of increase in number of photons. Intensity is number of photons. Okay. So photocurrent with intensity will be a proportional graph.
Straight line. Yes, sir.
So this interval, when phi is doubled, the saturation value will double. Suppose if this saturation value is 2 amps, this will be 4 amps. Okay, because this y-axis is current, and what will be this one? 6.
What is that one, sir?
See, this value for current, this current, no y-axis. Suppose if this is 2 amps. Okay, what is the next saturation value?
3.
No, twice, no, double.
Twice, sir.
Right intensity is double, no? Flux intensity has
Okay. Yes, sir.
So that means n has become 2n. Number of photons hitting the emitter plate has become 2n. That's the meaning of this, no? 2, 5, and 5.
Yes, sir.
So number of photons 2n means number of electrons, so the current will double. So this will be 4 amps. What is this current? Correspond to this saturation?
6.
6 amps. So this increase, it's a straight line variation.
Yes, sir.
When it's double means it's also double. So it's a straight line. And photocurrent with frequency. Okay, the saturation value will not change with frequency. Photocurrent is the saturation value. So the saturation
Yes, sir.
value is not changing with frequency. It is constant with respect to frequency. That's why it's shown like this.
Yes, sir.
And the kinetic energy of electron with intensity. So, h nu equal to phi naught plus k max. So it does not depend on the intensity. Phi naught is fixed, but and h nu is fixed because the frequency is fixed. So there is no dependence on this equation. So k max is independent of intensity. So it's a constant. Is this clear?
Yes, sir.
Okay. And kinetic energy of electron with respect to frequency. It's a direct relation because this is constant. Okay. So we have to draw k max versus nu. So what is the slope of this curve? The line. It's a straight line because k max is h into x-axis. Okay, nu is in the x-axis. So y equal to mx. So what is the slope here? H, right?
Yes, sir.
So k is y-axis and nu is x-axis. So y equal to mx plus c. Slope is m.
Yes, sir.
Okay, and there will be a minimum frequency for which the kinetic energy will be 0, because that h nu naught will equate to phi naught. In that case, the kinetic energy will be 0. Kinetic energy
Yes,
is
sir.
0 for when u equal to nu naught, and this f naught or mu naught is h by phi naught. Is that clear?
Yes, sir.
If
H by phi
you
naught.
access 0 in this equation, you get this one.
So second one, Alan, can you please explain H by pi naught?
See, if if this frequency is below a particular value, or at that cutoff potential, sorry, that cutoff frequency h nu naught, then it will be just equal to phi naught. Okay.
Yes, sir.
In that case, k max will be 0.
Yes, sir.
That's what is showing here. This point corresponds to the frequency being the cutoff value. At that particular frequency, h nu naught goes in completely compensating for this work function. H nu naught value is just sufficient to overcome that work function. So the kinetic energy is 0. So this point corresponds to kinetic energy being 0, right? So this is x-intercept.
Yes.
This point is
Yes, sir.
x-intercept. For that you have to put y equal to 0. So if you put y equal to 0, you get mu naught as phi naught by h. Okay, I made a mistake here. Base minus 1.
Yes, sir.
Is it clear? So x-intercept is phi naught by h.
Yes, sir.
Okay. The source of light is placed at a distance of 50 centimeter from a photocell, and the stopping potential is found to be V naught. The distance between the light source and the photocell is 25 centimeter. Then the new stopping potential will be.
Same thing.
Yeah, because when you increase the distance, the intensity is going down. But the energy of a single photon, h nu, that will not change.
So why does that number of photon will reduce, sir? I don't get that one.
This is a point source, no? Okay, even if whatever source may be, some source, it's emitting like this, no? So if we go farther and farther distance, the same source is good. The 4 photons is going on a largest surface area, no? Same energy or same number of photons is getting spread over a larger surface area.
Okay. Okay.
Okay, realistic spherical surface, 4 pi r square. Okay, so this spherical surface, it will be 4 pi r1 square. Okay, this is 4 pi r2 square. Okay, intensity is number of photons crossing per unit area. So if you take a unit
Okay,
area
sir.
here, and if you take a unit area here, since the number of photons is same and the same area, the number of photons crossing this unit area is less. It will go down as 1 by r square because the area is increasing by r square. So intensity will drop
So
down.
okay, intensity means we have to see that density only, yes, sir, not the
Number of photons
number of photons per unit volume.
per unit area.
Area. Okay.
Is the light flux crossing a particular area. It's like electric flux.
Yes, sir.
Okay. So light intensity is number of things crossing a unit area.
Okay.
So if you increase the distance, then the area to which the same number of photons is going is increasing by r square. Here is a point source.
Yes, sir.
Some other source will be slightly different from the point source, but will still be diverging. The number of photons is passing through a larger surface area. So the intensity will go down. Okay, so the stopping potential is independent of intensity. It only depends on h nu, but the frequency of the photon here and here will not change.
Yes, sir.
So since the frequency is not changing, stopping potential is not changing.
Okay.
Okay, when monochromatic light of intensity I falls on a metal surface, the number of photons and their maximum kinetic energy are N and T respectively. What is T? Maximum kinetic energy. Okay. Density of incident to I in the number of electrons and the maximum kinetic energy respectively. Yeah. Again, everything is based on photoelectric equation. H nu equal to the work function phi plus the kinetic. What is the kinetic energy here? Here its symbol is T, right?
Yes, sir.
Okay, so he's saying that the intensity has increased from I to 2I. Okay, so this equation will not change because this is equation for a single photon.
Yes, sir.
So whether the intensity has increased or not, this thing will not change. So uh, number of emitted electrons that will increase because one photon will emit one electron. So the intensity has doubled, the number of electrons emitted will be double. Number of
Yes,
photons
sir.
electrons will be double. It is 2n. But the maximum kinetic energy depends on this equation, which is independent of the intensity. This is for a single photon. Okay, so the T will be same.
Yes, sir.
Okay, intensity of exponential frequency of intensity. Okay, plotting frequency of the photon versus the stopping potential. The work function of the photoelectric surface is given by. Right. So this is the plot of the stopping voltage versus frequency. Sorry, incident y-axis is frequency. Y-axis is nu. X-axis is nu.
Frequency is plotted against that
Yeah.
stopping potential.
Yeah. So y-axis is the stopping potential.
Yes, sir.
Okay. So the frequency goes below a certain value. Particular value of frequency. Stopping potential. Okay. Basically, we use h nu equal to phi naught plus T naught. Okay. Yeah.
Yes.
H nu. Okay. So when the stopping condition, this energy when you apply the stopping potential, that the energy produced by the stopping potential that should be equal to, that should compensate for this kinetic energy.
Yes, sir.
Okay, so from this we get the relation between mu and v naught. Here this is x-axis and this is y-axis. Okay, so this means, okay, we have to find the work function phi naught. So phi naught is the, when you put y equal to 0, phi naught is the x-intercept, right? So
Yes, sir.
phi naught is
H mu.
phi naught is x-intercept. X-intercept is what OE, right? OE divided. Yeah. Is OE. And okay, fine. That if you put x equal to 0, okay, then also you get phi naught. Phi naught is y-intercept minus y-intercept, that is minus OB divided by, that's also true. What mistake I made? Sorry, this is y-intercept B naught. So y-intercept is OB divided by E. It's minus OB by E. Okay, according to the third option is this one C. Got it, no?
Okay. Yes.
Either is h nu equal to phi naught plus k, and this stopping voltage condition, this kinetic energy will be suppressed by this stopping voltage. So kinetic energy will become equal to E into V naught. So we have a plot between V naught, that's a y axis, and V naught is the x axis. So to find phi naught, we can put y equal to 0, then it is x-intercept, it is OE, or we can put x equal to 0, so that is y-intercept EV naught, and x-intercept is V naught, so it is E into x-intercept is E V naught, so that divided by E will give me phi naught. So it's either, so correct option is option C.
So OB by E alone, can you please explain once again? Minus pi naught, okay. Minus pi naught by E means.
Am I making some mistake? See, y-intercept is EV naught, right?
Y-intercept is minus pi naught by E, sir. I don't know where is that pi naught present here.
But see, one way of getting phi naught is putting this y equal to 0. So x-intercept is h naught, right? So x-intercept is h naught. Yes, OA. So this one is definitely true. OA is OA never come out. Okay, and if you want to put in terms of y-intercept, so whatever is the y-intercept, you have to divide it by e.
Yes, so that will be pi naught minus pi naught by E.
Sorry, y-intercept will give me the value of v naught. So I have to multiply the y-intercept by e. Okay, into e. So both are true then. It's into e. Y-intercept will give me the value of v naught, right? So if you multiply that into e, I'll get my phi naught. So option 1 is also true.
I don't get it, sir. That's like first option. How does it come true?
See, phi naught I can get by putting x equal to 0, right?
Yes, sir.
So that will give me y-intercept. And y-intercept is basically e into v naught, right? Sorry, y-intercept is just v naught.
Huh.
Okay, so that y-intercept will multiply by e, that will give me phi naught.
Yes, sir. Yes, sir.
So that is option A. Y-intercept
Yes, sir.
will be into e. So option C is also true then. I can also get. Okay, actually this thing does not exist. That is the logic. The frequency, if it is less than mu naught, then there won't be any photoelectric effect, no? Photoelectric effect is only from this mu greater than mu naught. So only this x-intercept will make sense. X-intercept is frequency. So only h nu will make sense. So option B is no, this thing is not true. Option E is not true.
Yes, sir.
Only option B is true. Y-intercept does not exist. Okay, actually in lab, no, you can just extend it by dotted line. It's not a physically realizable thing, but still we can extend it by dotted line and we can get this value.
Okay, sir.
But it's not realistic, but still it will give me the answer. Okay, if frequency of light on a metallic level, how will the maximum kinetic energy? This is a trivial question.
It will also come double.
Frequency is double means okay.
It will be lesser than double, sir.
Yeah, so I think we can just put a Just take an example of E becoming 2E. Okay, so kindly. Okay, frequency is doubling means this is becoming H2 nu minus 5. You have to compare it with H2 minus 5, right? So it's exactly double.
Sir, can you, what did you write on that note, sir? I can't understand.
Hold on. We just have to find the maximum kinetic energy, right?
Yes, sir.
This is the photoelectric equation,
Yes, sir.
and this is H nu, right?
Yes, sir.
So in the second case, K max is H into 2 nu minus 5, right? In the second case, the frequency is doubled. Energy is H into 2 nu minus 5. This is K max. In the first case, the K max is H2 minus 5.
Yes, sir.
Okay,
Sir, if we put numerical value means it becomes more than double, sir. For example, we fix that value of 5 as a number like 1 or 2 and take that E as 5 means 5 minus 3 equal to 2 and second time 10 minus 3 is equal to 7.
fine. You have to compare 10 minus 2 and 8 minus 2, right? So it is 8 compared with 6. What am I doing?
What did you write, sir?
Okay, I made a mistake.
10 minus 2 and 20 minus 2, sir.
No, for 5 minus 2. So this is 3 then. It's more than
Yeah.
okay, fine. I don't think this sort of questions will come. Okay, for certain metal, use increase. Okay.
So that won't be a straight line, sir. So kinetic energy and frequency relation will be parabola or something
Kinetic
else.
energy and frequency. No, straight line won't do. H nu equal to.
Straight line means it should become exactly double, no, sir. But this is not exactly double means maybe
See,
curve.
no. See, there are two different lines. It's not the same line. I am changing E in terms of
Slope is not constant, no, sir, here. So it's not a straight line.
no. Yeah, actually, this thing is suppose frequency of nu, then the equation is 5. I change the frequency to mu1, 5 plus k1. Okay, for a given frequency, the relation between H, this kinetic energy max is not independent of. Okay, we just leave it. From numerical, it's beginning to be more than this one. So, okay, this one. Yeah, the mic is off.
5.
So H new equal to y naught plus k max, no? So then it is 5 mu naught.
1/4
Yeah.
times.
So basically there are two cases. H nu 1 equal to 5 naught plus k1 and H nu 2 equal to 5 naught plus k2. Okay. So so nu 1 and nu 2 we know the relation 5/2. Okay. So if we divide these two, nu 1 by nu 2 equal to 5 naught plus k1 divided by 5 naught plus k2.
B/2, sir. So 4
Yeah. And 5 naught
into
is
10%.
yeah. And another relation is 5 naught is nothing but H nu naught.
Yes, sir.
So got the answer?
Yes, sir. K2 will be KE 1/4. So V2 will be KE V1/2.
So option A.
Yes, sir.
So the important thing to realize here is H nu equal to 5 naught plus k, and in terms of nu is given in terms of nu naught. Okay, in two cases, and 5 naught is nothing but H nu naught. This is the important thing to realize.
Yes, sir.
So once you know that, you will get the answer.
Yes, sir.
This one.
Now function changes. Okay. Now the conditions are changed. Then cathode of a potential change means it means that voltage is changed, sir.
So when the material of the change is work function depends on the material of the cathode, no? So work function will change.
Yes, sir.
Yeah, the intensity of the saturation current depends only on the intensity of the incident photon, not on the work function. So it should be same.
Yes, sir.
The number of photons will decide. The only the condition is okay. The condition is the photon frequency should be greater than mu naught. Okay, but that we assume it's true. Only then there will be emission. Okay, here that is true. Only the work function has increased. If the work function is increased,
Frequency is increased.
okay. So the only condition is this. Uh, this mu naught, it depends on the work function, no? It's 5 naught by h. So the only condition is both the frequency nu should be greater than the work function h nu should be greater than w1 and w2. This is the assumption we are making. Okay, in that case, the number of photons emitted in both the cases, the number of electrons emitted in both the cases will be same. That means that the current is same. That is saturation current is same. Suppose the second work function is very large. then there won't be any emission of photoelectron. But in the first case, there will be emission of photoelectrons equal to the number of photons. So this assumption, it's made. The incident photon is sufficient energy to knock off electrons.
Yes, sir.
In that situation, the intensity will be same. Okay, this one, 2020 question. Light of frequency 1.5 times the threshold frequency of the material. What will be the photoelectric current if frequency is half and intensity is doubled? Frequency 1.5 times threshold. Okay, what will be the photo current if frequency is half and intensity is double?
Intensity is doubled means photocurrent also will be doubled, sir.
But the one important condition is, see, the frequency is 1.5 times nu naught. That is the first. Okay, so now
emission will be there.
So now the frequency is reduced. So the frequency will become 0.75 mu naught. So the frequency in the second case is less than mu naught. Okay, so the photocurrent will be 0.
Okay. Yes, sir.
Okay, so the current will increase with intensity only under the condition that the frequency is greater than mu naught.
Yes, sir.
Here's 2019 question. Work function of a photosynthesis 4 electrons. Longest wave of that can cause photo emission is approximately. You can always start with the photoelectric equation. Work function so you have to find mu min. That is same as mu naught. So mu naught is 4 electron volt by volt. Because when mu is mu min, that is same as mu naught, K max will be 0. Is that clear?
So electron volt, how can I convert into that?
So we have to convert it to SI units. So 1.6 into
Joule
into 10 raised to minus 19. E stands for 1.6 10 raised to minus 19. So this is 6.63 into 10 raised to minus 34.
Three into 10 power raised by 4 into
10 raised to minus 15 meter. So it's minus 10 raised to. What mistake am I making?
So HC by lambda naught. So you have asked lambda naught, sir.
Yes. So this is mu naught. Oh, we have to find lambda, right?
Yeah.
Actually 10 raised to plus 15 mu naught. So lambda naught will be 3 into 10 raised to 8 divided by 10 raised to 15. So that is 10 raised to minus 9. So do it properly. Is it this one? Okay, it's 4 electron volts, so 4 into 1.6 divided by 6.6. I think that is approximately cancelling, no? 4 times, and half of 4 is around 6. So, oh, 3 is there, no? Yes. This 3 is going to give me 31. So it's 31 only. What mistake I'm making? 10 raised to 8, no, 10 raised to 8 divided by 10 raised to 15. So 15 minus 8 is how much? 15 minus 8 is how much?
-7.
It is 7, no? So it is 10 raised to minus 1, so 100 nanometers. So it's D. Got it? If 4 into 1.6 divided by 6.6 will cancel. You have to find it approximately. Okay. Exact calculation is not required. So is it clear? 4 into 1.6 by 6.7 will cancel.
Okay.
So only 3 will remain, approximately cancel. So only 3 will remain.
Okay,
It
sir.
will come out to be 300 nanometer. So that is 3 times.
Yes, sir.
Okay, this one another frequency. I think you already done, no? No, slightly different. The first case new is 2 need not. Okay, new was the crystal frequency. Maximum velocity
1:2, sir.
V1.
Same case only, sir. Last.
Yeah. And the second is, yeah, again, find out is H naught. C, option C.
1:2.
Got it, no?
Yes, sir.
The important step here is find out is H naught.
Yes, sir.
If you miss that, you will not get it. This one, this is lambda naught. Okay, I think you not use for stopping potential. I don't know, you have to be careful. Lambda naught, or you can use lambda TH. Velocity of the electron ejected from the silver surface. Okay, this is straightforward. I will use that equation only.
It's a lengthy calculation.
No, I think you just have to do approximate. That's why you are doing approximate, no?
Index.
Lambda is okay. This is oh no. So this is actually okay. I think for the okay. This is actually before putting the numbers, you just have to simplify it and then finally put the numbers. So it is Hc by lambda equal to Hc by lambda threshold plus K max. Okay, this is half mv square. So it is Hc into 1 minus lambda divided by 1 minus lambda threshold equal to K. Okay, 1 by lambda, 10 raised to 10 is there. So HC into 10 raised to 10 divided by 2536 minus 1 by 3250 equal to half m v square. Yes. Yeah, but you have to do, there is no like, got it? Uh, you want to continue?
Yes, sir.
Okay, fine. I thought you were tired.
No, sir.
Okay, this one,
My
metallic
laptop was
surface.
restarting.
Okay, this one, metallic surface illuminated with radiation lambda. The stopping potential is V. So, your headset is working or not?
Yes, sir.
But the
Now
background,
I'm using headset only.
but the background noise is there. So, you're using headset with mic or not?
So you only asked me to switch to laptop's microphone, sir.
Yeah, yeah, but there was previously. But what is happening right now? Is it still a problem? Background noise is not there, but I'm not able to hear you. Are you using the mic now? I can't hear you now. No, switch to laptop mic.
Now it is switched to Bluetooth microphone only, sir.
Yeah, I can hear you. So you're using what, mobile?
Yes, sir.
Okay, now also background noise is there. Fine. So try this problem. Okay, so we have two equations and two unknowns. Um, so this thing I can write as hc by lambda, right?
Yes, sir.
I have two values of lambda and two values of v naught, and this k max is e v naught, where v naught is the stopping potential. Okay, so I have two data. So I'll have two equations. So I have to find threshold wavelength, right? Threshold wavelength is what I have to find. So this is equal to h mu naught. Okay, and this is equal to hc by lambda threshold. So basically, I have to find phi naught in terms of lambda, because answer is terms of lambda. So I have to eliminate b. Okay, so from this
3
two,
lambda, sir.
yes, you got it right.
Yes, sir.
Okay, this one.
What are you telling me? Maximum energy of the production, that is a kinetic energy, sir.
Maximum energy, yeah, there is only a, see here, there is only one form of energy, no, kinetic energy. After that, once it emits, once the work function is overcome, just kinetic energy. Maximum energy is kinetic energy.
Three volts, sir. Second stopping potential.
These are the two data, right? The first case, this is 5 electron volts. So this thing is 2. In the second case, it's 6 electron volts. This is 0. Okay. So I have to find stopping potential is
V not is free, sir, but I don't know what is that V anode and V cathode. We have to
okay.
equate that
So,
finite value for both the cases, sir.
so in the second case, H nu naught is energy.
That in kinetic value will be E B not dash. So if we equate that finite value, we will get that second potential, stopping potential value. But I got a free also, sir.
Okay. So in the second case, this has got some kinetic energy. It's not zero.
Like, what is the duration?
Your voice is not clear. Your laptop mic was better.
So in both the cases, work function will be constant, no, sir. So we have to equate that work function in both the cases, sir. Then you will get that answer for the second stopping potential.
Yeah. So in the second case, there will be some kinetic energy. So this should be equal to EV naught.
Ah,
Okay. So from there, I'll get V naught.
yes, sir. First case also E V not only, sir.
No, but that V naught is different.
Ah, that's what I'm saying. Will be V dash or something.
So what is the answer?
I got the answer as 3 words, but I don't know what is that cathode potential and anode
Yeah,
potential.
yeah. Cathode is negative, no?
I simply got that the stopping
And
potential value is 3 volts, sir.
hold on. Cathode is negative, anode is positive, no? Cathode
Yes,
will
sir.
emit electrons. So we have to find, okay, the stopping potential of VA relative to C. So it's VA minus VC. Same with the relative velocity concept now. Velocity of something relative to something means velocity of that A minus velocity of B. So velocity of stopping potential of A relative to B means VA minus VC. VA is okay. And stopping potential means I'll be applying a negative voltage here. So V is negative. Okay. So it's minus 3 minus whatever it is. So VA will be negative.
Like,
Okay. So actually this difference is 3. So it's minus 3.
sir, can you please explain once again? I can't understand.
See, stopping potential is he's asking E relative to C. No. So you have to find VA minus VC. Is that clear? Is that clear? He's asking
Yes,
stopping
sir.
potential of E relative to C. That means VA minus VC.
Okay.
Maybe same as a relative motion, right? Velocity of A with respect to B is VA minus VB.
Okay, sir. Here, what is the V and VC value?
See, the thing is, when you're trying to stop it, the electrons are coming from here. No, to stop it, I have to make this plate negative.
Yes, sir.
So VA is negative compared to C.
Okay.
Okay, so VA, so that is VA minus VC will be negative then. VA minus VC is the
Yes, sir.
potential difference from here to here, no? And
Yes,
this should
sir.
be negative. So it is minus 3.
Okay, sir.
Okay, shall we stop now?
Fine, sir.
Okay, we'll continue tomorrow. 3:30. Okay, then bye.
Bye, sir. Sir, shall we change the timing, sir?
What timing?
6 p.m. if it is convenient for me, sir.
No, no. What about 11:30 in the morning?
11:30 means my brother will take the laptop, sir.
Okay. No, the 3:30 is the only time. Evening time I'll be busy.
Okay, fine.
Okay, so I'll meet at 3:30 then.
Okay. Night also you are busy, sir.
Yeah, yeah. Either 3:30 or 11:30 in the morning.
Okay, sir.
So
Before
tomorrow,
that, early
what?
7 o'clock.
In the morning?
Ah,
No, no.
okay, sir. Thank you.
Okay, bye.